An AI agent is not just an LLM, it's LLM plus tools. So the danger is not can I trick the LLM into doing something bad, but danger is can I trick an LLM to perform malicious activity with its tools. Meet PwnGraph. PwnGraph is a runtime attack graph engine for AI agents. It will test your AI agent in runtime. It will fire malicious payloads across 6 different attack classes in real time, and it will prove the attack chain if there is an attack chain possible, and it will also convert your attack chain into graph structure so you can easily visualize this. Just think like bloodhound but for AI agents. So here is our target. It's an AI agent LLM help chatbot. You can find this in this repo. You just need to clone it and you are ready to go. As you can see, this AI agent have knowledge base, proper commands, also templates, workspace, and this is the core code. So let's test this. You can read the docs here. You can also download PwnGraph by pip install PwnGraph, and also otherwise you can also clone it. You just first need to run the PwnGraph doctor. This will check is our tool ready to go and test any agent. If not, it will show the error. As you can see, everything is fine. We also need to provide our API key to generate the adapter file. Then we need to run PwnGraph init to generate an adapter file. So what is adapter file? Adapter is how you point PwnGraph at your agent. You just give it your target object in one small file and PwnGraph handle the rest. As you can see, our adapter file is generating. As you can see, our adapter file is generated. So let's first start the attack, then we'll understand the PwnGraph in depth. As you can see, this is the default command. This will take 25 iteration by default. We also can modify iteration in CLI, whatever we want. As you can see, this adapter file we generated. Here is this adapter file. This is the bridge between our PwnGraph and AI agent we want to test. It is performing 25 iterations and 1 trial and 3 baseline. As you can see, attacks are started. Let's understand PwnGraph CLI in depth. As you can see, it will fire payload according to class, a different vulnerability class. So let's start. First, we can perform PwnGraph -help. It will shows the help section. As you can see, these two options are available, and these are the four commands. Doctor, we need to use to check is our tool correctly configured or not. We need to generate the adapter file. List attack, you can list the possible attacks here, and scan. This is our main command. Let's see what are the customization we can apply. Okay, first this is the options. First we need to choose the target file, which is our mostly adapter file. Then attacks, we can put all to perform all attacks, otherwise we can just take the attack, particular attack we want to test. Iterations is number of payloads per attack class. Default is 25. We can also pass 10, 15, 20, 100, 200. And trials, it will give the same payload multiple times, because LLMs are non-deterministic. It's not like if LLM is rejecting one payload means it will not take that payload. Maybe in ninth or 10th attempt it can perform the attack. That is what the whole point behind the tool. As you can see, hyphen payload, we also can give the custom payload, because uh, over the period of time AI agent will become more mature, so we need to generate more mature payloads. It's consider it as like a nuclei templates. As you can see, here are some templates present. Over the period of time, we will also increase the templates. We will call the security engineers from all over the world to contribute here to make this template database more mature. When you provide hyphen payload, it will it will pass the custom payloads plus our default payloads. But when you pass just hyphen payload only, it will just pass the custom payload. So, and this is our core architecture. PwnGraph have 5 modules: connector, fuzzer, tracer, graph builder, and reporter. The connector will attaches to a live agent, discovers its tools. The fuzzer crafts adversarial payload attacks, embed canary into each module. So actually, each and every payload will have the unique canary token. Whenever we got that canary token in the tool call, we can prove the attack chain, how it passed through and how it exploited. Like what every tool it take and what attack it generated. With the help of connector, we can integrate any framework. As you can see, as of now here we just this is a initial version, so we just integrated LangChain and LangGraph. If you want to integrate GenAI or Crew AI, if you want to integrate Crew AI or AutoGen, we just need to give the .py file for the tool calls and architecture, and PwnGraph will take care. This is further, as I told you, this will further the payloads based on keywords what tools access the AI agent have. It will generate the payloads. The each and every payload will be different, and there will mutation also. Some are base64 URL encoding, maybe some are another encryption decryption also we added here. As you can see, then tracer, it will trace each and every tool call the AI agent is making. Then graph builder, it will generate the graph. As of now, we integrated the Jinja to Python template, so it will generate the interactive graph. and it also will generate the report according to the findings it have. Okay, it will take more time. As you can see, we are in the final stage to get the results. As you can see, we got the results for this particular attack. As you can see, the graph is opening. Again, you can see we use the GPT-4o mini model for this lab. Also, it generated the results here. Output arsenal. You can see here. It generated the five files. Attack graph. This is our attack graph UI. Delivery.json. It will give us the total metadata. Findings.serif. It will give us the GitHub level format. So we can also integrate it in some other tool if you want. This is reporter.html, the clear report, and trace.json. We can see the proof of each and every tool call and the tracing here. As you can see, there are total 11,000 of lines of code. So you will get this type of page after the result. Now you can see this is our results. We can just click on findings. There are total 6 findings. 4 critical and 2 high. As you can see, this is the full attack path. If you search on click on danger, it will give you the all results like this. You can see the attack chain. These are also interactive graphs. You can again, this is the critically found, too high, web search, and 7-node feature. If you just want to sort by attack path only, you can click here. It will show you. If you just want at critical only, it will show the critical only path. If you just want choke point, you will get the choke point. You can also open the report by clicking here. So this is our report. For critical to high, 20, attack surface rate is 25%. Attack surface rate means it passed total 150 payloads and 37 out of them 37 payloads are successful with confidence level. As you can see here, shell injection is more confident in this case. As you can see, mapping of WASP LLM top 10. This is the dangerous attack path. We can see first two attacks are in 2 hops. These two are in 3 hops. You can also see the attacker chain here, and you can also copy payload, and you can also put it in your report. And because there is candidate token also, this is the proof of the attack chain. These are the reports with CVSS score. Okay, that was our report.